All right. Hello, everyone. So in this video, I'm going to cover the second half of the ions and ionic chemical formula notes. Okay, so in the first part, we talked about monatomic ions, ions made of only one type of atom. Okay, and I had listed some here, and I showed you how to find them or how to figure out the charges from the periodic table, stuff like that. Okay, the thing we're going to go over today is polyatomic ions. These are ions created from two or more types of atoms or elements. So instead of just one element, they've got multiple elements as one ion. Okay, so examples. And again, you can link up. So I'm going to actually switch this so you can see. Yeah, okay. So what I've done here is I just highlighted the four terms here: the cation, anion, monatomic, and polyatomic. Okay, and then excuse me, I just highlighted down here to show you that essentially these four ion categories are just combinations. It's one of the two, either cation or anionic, and then it's one of the two, either monatomic or polyatomic. So you get cation with monatomic, you get cation with polyatomic. You get anion with monatomic, anion with polyatomic. And that makes the four combinations here. Okay, so some examples of polyatomic cations, positively charged: NH4 plus 1 and H3O plus 1. Okay, there's not really a lot of polyatomic cations. There actually are very few. Okay. Polyatomic anion, the negatively charged ions. So here's some examples: OH negative 1, NO3 negative 1, SO4 2 negative, PO4 3 negative. Now remember, the numbers in the subscript are numbers of atoms, not part of the charges. The charge is in the upper right corner, and the charge is on the whole molecule. So like, if we're looking at, move this up again here a second. So if we're looking at like these, so the entire thing has the charge on it. So the OH, that whole thing is a -1 charge. Okay. Same thing with these. Like SO4 is 1 sulfur and 4 oxygen, but all of that combined together, the SO4, all of it combined together has a 2 negative charge on the whole thing. Okay. All right. Now, you can, if you want to write this down on your notes, you can. You can just pause the video. Ion charges. I told you guys some of this yesterday. Monatomics come from the periodic table. For example, phosphorus is in 5A, it wants to gain 3 electrons, so it's going to make a P3 negative charge. Transition metals have Roman numeral in the name to give the positive charge. We talked about that. Polyatomics, you have to, if they don't give it to you, you have to look it up. I will give you a polyatomic sheet at some point. The homework that you have for tomorrow, you don't need it, but I'll give you a polyatomic sheet. Or if there's one that's not on the sheet that I give you, you can just Google it as well to figure out what the polyatomic formula is, the ion formula. Okay. All right. So we're going to go to the back of the notes. All right. And okay. So Again, yesterday we were doing just the ones with the monatomic, the single. Okay, that's why I skipped over number 2. And number 2, you can see it has a polyatomic in it here. Okay, so we're going to still use the crisscross method, just like we were doing yesterday. Okay, so with these, we have SR, 2 plus, and OH, 1 minus. Okay. Now, you cross down. Okay, this would tell us we have SR, we just need one of those. And we would have 2. Now, here's where you have to be careful. On a polyatomic, if you're bringing a number other than 1 down, you need to put parentheses around it, because we want to say we have 2 of these whole things. So let me kind of diagram out the concept on here for you as well. Actually, I'm starting page. Okay. So formula creation with polyatomics. All right. So let me zoom out just a little bit so we can see what it is. Okay. What we have here is the SR. I'll try to use some little different colors so the SR is a 2 plus. Okay, the OH, so the SR, 1 SR is a 2 plus. The OH as one thing is a 1 negative. Okay, so you have to ask yourself, if you're combining these in a formula, how many of each do you need to be balanced or to have a neutral or no charge? Because remember, that's the goal of the compound. So we've got a 2 plus here, we've got a 1 minus here, so we need to add another OH, right? So we add another OH, which is a 1 minus. Okay, and now, if you total it up, okay, over here we have 2 minus. Over here we have 2 plus. So it's neutral. Okay, now if we look at this, how many of each thing do we have? Well, the SR, we've got 1 of them. Okay, we don't have to put the 1 down. It's understood. The OH, this polyatomic, we have 2 of them. Okay, but look here, it's not, if you just wrote, excuse me, if you wrote it like this means you have 1 oxygen atom and 2 hydrogen. Okay, this means you have 2 oxygen and 2 hydrogen, which is what we want. So it's like in algebra when you distribute something outside of parentheses. Okay, so if you if you had I'm trying to think of how, like, if you had something like 2, so 2x plus y means you have 2 x's and 1 y, right? But if you have 2x plus y like that, that means you've got 2 x's and 2 y's, right? Okay, so when you're making it, we've got one SR and we've got two of the OHs. So we need to say we have two of that whole thing. Treat that as one whole thing. So it should look like that. Okay, and that would be your formula. Okay, now let's take a look at some more down here. Okay, we have let's see. Okay, potassium sulfate. The 8 part of this tells us, hold on, let me move it up a little. The 8 part of this tells us we have a polyatomic anion. And you get it from the sheet or online. Okay. So the ides, with some exceptions, but usually the ides mean it's a monatomic anion from the periodic table. So if it ends in something, if it's not an ide at the end of the anion, then you know that it's a polyatomic. Okay. So potassium, we look up on our periodic table. Potassium will be in row 1. Grab my table here. Potassium is in row 1A, so it's plus 1. So K is a plus 1. And sulfate, you'd have to be given or look it up, and I'm telling you what it is. It's SO4, 2 negative. Okay. So we cross down. Okay. And we would get K2 SO4 1, like this, right? Because we're bringing a 1 down from the K. Now, when we have something like this, so when we have something like the K2 SO4 1 like this. Remember, anytime we have a subscript of 1, we don't need to put it, because just by writing it in there, we're assuming that we know we have one of those. So this is sort of like, if we go back to the algebra example, we don't have to write 1 and then put x plus y in parentheses. We know we have, if we're writing down x plus y, that's assuming you have at least one of that thing. Okay, so we don't have to write a 1, which means we don't need parentheses on that. So this actually will be written like K2 SO4. All right, we don't need the parentheses on it. Okay. So you only need parentheses if you're bringing a number down other than 1. Okay, let's take a look at the last couple here. Aluminum nitrate. Okay, we look up aluminum on the periodic table. It's a 3 plus. Okay, nitrate, again, the ending tells us it's a polyatomic. Nitrate is NO3 negative 1. Okay, we cross down. Okay, we end up with Al. We don't have to put a 1 on it. And then we're bringing down a 3 onto the NO3. So we need parentheses around the NO3 because that's our polyatomic. We want to say we have 3, we're bringing the 3, so it looks like that. We want to say we have 3 of these entire thing. All right, let's take a look at magnesium carbonate. Magnesium, we look up on the periodic table, Mg is a 2+. Carbonate, again, a polyatomic. I'll give it to you as CO3 2 negative. Now, just like the others for ionics, you check your charges. We can reduce these as we're doing it. So it reduces to 1 and 1. So we've got Mg plus 1, CO3 negative 1. Then they cross down. We end up with just MgCO3. No parentheses are needed because we're just bringing a 1 down onto the CO3. Right? Okay. So that's pretty much it for the lecture. I'm going to go to the homework here. I'm going to walk through a couple here just to make sure that you guys know what you're doing. Okay. So all you're doing here is this is like a grid. You're combining the cation with the anion. Okay, and the cation always comes first. The positive thing always comes first. So all you're doing is like here, you've got Na, and from the anion up here, you've got Cl negative. And then you're just reducing if you can. If not, then you're just crossing down. So we get NaCl. Okay. So, and then you just keep combining. So like this one here, this box is going to be the Na plus 1 combining with the CO3 negative 2. Can't really reduce anything. You cross down. We end up with Na2 CO3. We don't need parentheses because we're not bringing anything other than a 1 down. Okay. All right. Let's take a look at this one here. Okay. Let's take a look at this one. So we're combining a polyatomic cation, NH4 plus 1, with a polyatomic anion, CO3 negative 2. Okay, you look at the charges, they cannot be reduced. So we cross down. Okay, and remember, guys, whenever you have the polyatomic ions, you never change those subscripts. That has to stay kind of as like one thing. Okay, so like this 2, you're not going to do anything with the 4 with that. All you do, just like we're doing with the other ones, is when you're bringing a number other than 1 down onto a polyatomic, you have to use parentheses. So this needs to be parenthesis NH4 and then the 2 on the outside because we want to say we have 2 of the whole thing. And then we're bringing a 1 down onto the CO3, so we don't need a parenthesis with that. So this should look like this. Parenthesis NH4, parenthesis 2, CO3. Okay. Also a reminder, remember to make sure that you are doing capital letters where they're supposed to be capitals and lowercase where they're supposed to be lowercase, so you don't get them confused. All right. So let's go down to here. Let's do the Ca and then the OH. Okay, so the Ca plus 2 and the OH negative 1. Okay, this is one that sometimes people forget. They sometimes forget that hydroxide, the OH, is a polyatomic because there's no subscript number here. But we know it's a polyatomic because there's 2 capital letters, which means 2 different elements. Okay, so we have this when we cross down. Okay, we get Ca And then we need 2 of the whole thing. So the OH has to be in parentheses because we want 2 of that whole thing. Okay. All right. Let's see. What else? Really, the only other thing is just watching out for reducing. So, like, if we do here the calcium, so the Ca plus 2 and the CO3 minus 2, we can reduce those charges, divide them both by 2. So that becomes a +1 and a -1. And then when you cross down, we end up with CaCO3. No parentheses needed because they're just bringing down ones. Okay. All right. So your assignment then is to finish this. If you get, I would recommend for finishing this up and doing this that you show the crossing down or whatever. However, I'm not going to take off points if you don't show that. Okay. I'd recommend at least starting with that until you kind of get used to it. Then as you get used to it, you might be able to just look at the positive and the negative and know what it's going to be. Okay. So just a little bit of advice on that. If you guys have any questions, so when you're finished with this, make sure you upload it. If you have any questions over the weekend or anything, hit me up on Remind or Google Classroom or something like that. All right. Have a good one. Good luck, guys.